Hello friend, today our topic is related with geotechnical and in this topic I will explain about Terzaghi bearing capacity theory for solid foundation, and this topic is very important for all examination point of view. And first see its assumption and explanation. Terzaghi 1943 derived a general bearing capacity equation for shallow foundation from modification of equation proposed by Prandtl. This equation is derived based on neglecting the shear resistance of the soil above the horizontal plane through the base of the footing and replacing the soil above the plane with surcharge Q is equal to gamma df. And let's see its assumption. First, footing is a strip at shallow depth. Df is equal to V and I is a rough base. Second, problem is essentially two-dimensional general shear failure with well-defined failure surface zone as indicated in the figure A. Figure I will explain later. Assumption number 3, the soil is homogeneous, isotropic and relatively incompressible, and its shear strength is represented by column equation. Assumption number 4, the failure zone do not extend above the horizontal plane through the base of the footing. The number 5, the overburden soil is replaced by uniformly distributed equivalent surcharge Q is equal to gamma df. Assumption number 6, the effect of water table is not considered. Assumption number 7, the ground surface is horizontal. Assumption number 8, the principle of superposition is valid. Assumption number 9, the shear resistance of the soil with the depth df from the ground level is neglected. Depth df from the ground level is neglected. And let's see its limitation. This theory does not consider the effect of water table on bearing capacity. In this theory, the effect of depth of foundation is not considered. This theory is applicable only strip footing, only for strip footing, not applicable for other like rectangular, square or circular foundation. This theory is applicable only for strip footing and not applicable for other like rectangular, square or circular foundation. And limitation number 4, this theory only vertical and symmetrical loading are considered. In this theory, only vertical and symmetrical loading are considered. And we will see its explanation. Now we will see explanation. Here is figure, and it is divided into 3 zones. 1, 2, 3, and 1, 2, 3. 3 zones. And this is the depth of footing. And this is load, this is footing, and this is width of footing. And let's see. Terzaghi assume strip footing with rough base. Place at the depth df on a homogeneous and isotropic soil medium. Strip footing with rough base. Place at distance df on a homogeneous and isotropic soil medium. In the analysis, the shearing resistance of the soil above the base of the footing is not considered, but the effect of the soil above the base is considered by superimposing. The shearing resistance of the soil above the base of the footing, is not considered, but the effect of the soil weight above the base is considered by superimposing an equivalent surcharge intensity Q is equal to gamma df. Effect of the soil weight above the base is considered by superimposing an equivalent surcharge intensity Q is equal to gamma df. The development of failure surface in the soil is governed by general shear failure. The development of failure surface in the soil is governed by general shear failure. The failure zone under the foundation can be separated into 3 parts. I already told zone 1, zone 2 and zone 3. Zone 1, zone 2 and zone 3. The triangle zone ABC immediately below the foundation is an elastic zone and zone of active state. This zone, triangle, this is triangle, immediately below the foundation. Below the foundation is elastic zone and zone of active state. And the zone 2, this is the zone of radial shear, ADC. This is the zone of radial shear. Zone 2, ADC. This is A. ADC, this is the zone of radial shear. This one, this is the zone of radial shear, and BCD1, BCD1, the curve DC and CD1, curve DC and CD1. CD1 are the arc of logarithmic spiral. And this is the zone of plastic equilibrium, zone 3. This is the zone of plastic equilibrium, ADE, and this one is BD1, E1, plastic equilibrium. And using equilibrium analysis, Terzaghi expressed ultimate bearing capacity in the form of Q is equal to CNC gamma D of NQ plus 1 by 2 gamma B NY for straight footing only. Terzaghi doesn't consider circular, rectangular or a square footing. This equation is valid for only straight footing, where C is unit cohesion, gamma is equal to unit weight of swell, and B is equal to width of footing, depth is equal to depth of footing, and C, NQ, NY, and C, NQ, NY, the bearing capacity factor that are not dimensional, it has not a dimension, where pi is equal to 0, and C is equal to 5.7, and NQ is equal to 1, and NY is equal to 0, and Q is equal to 5.7 plus gamma DF. When pi is equal to 0 and NC is equal to 5.7 and NQ is equal to 1, NY is equal to 0, then Q is equal to 5.7C gamma DF, and for a surface footing Q is equal to 5.7C only. That's it for today. Thank you guys. Please like, share and subscribe. Next day I will bring new topic of geotechnical. Thank you for today.